Hey guys and gals. So today you guys are going to be working on this paternity lab. So we're going to try to figure out who is the dad of the little penguin. So there you have a little cute picture of some baby penguins, but we're going to use those skills that we learned last time with restriction enzymes in order to do this. So we have a little bit of background here. Make sure you guys read through that. And then here we have the different males that we are going to be looking at. So a lot of times in like zoos or farms, they give numbers to all of the animals, kind of like their barcode almost, and they'll put like a oh my goodness gracious, they'll put a leg band or they'll tattoo their ears or do something like that in order to mark those animals. So you guys are going to be doing that to make the DNA fingerprint. Down here, make sure you read through the procedures, but the very important part that I bolded and read for you guys is read through each segment of DNA, and whenever you spot the sequence CCTA, underline it and draw a dash after the T. So I have a little example here using this little weird X symbol, but you can use any symbol you want. So you can just put like a dash or a slash or anything like that to help you, okay? So we'll go through the chick together and then you guys can do the other ones. And feel free to like work with each other, like set up a Google Meet or FaceTime each other, work through it together. Makes day go by a little bit faster if you have a little bit of contact. So once again, we are looking for CCTA. So I'm gonna look through here. Oh, right here I see my first CCTA, and that cut is made between the T and the A. So I am just going to add in a slash, and just for me, I'm going to bold it and put it in a different color so I know that that is actually a slash. Okay, so I'm going to look for my next CCTA. There's another one. Then I'll keep going and looking at all of those. Okay, so I just went through and put in all of my dashes for those different fragments. So now down here, you need to count out the fragment lengths. So each fragment that we have, so I'll just bold every other one, so it's a little easier for you guys to see the differences between these. You are going to go through and count how many letters are in each fragment, just like I did with the example last class. So just for an example, this first one here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our first one is 13 bases long. So I'm going to go through and count all of them and then type that down below. So I went through the whole chick, and they have a section that's 13, 10, 17, 6, 14, 10, 6, 8, 6, and 7 long. So you guys know from last time that those are the chunks that got cut by our restriction enzymes. And you also know that all of the genes from all these penguins, we have to sequence the same gene. So we could be looking at the X chromosome or the Y chromosome or the cytochrome C gene. We're looking at the same gene in all of these penguins, but they're all going to be slightly different because of the different mutations that these penguins have. So once you've sequenced out all of these penguins, what you are going to do on the next page is here is the gel. So we have our little chick up here, and we would put our DNA all in this well. And then when we turn on the electricity, that DNA is going to migrate with the smallest pieces going the farthest, and the biggest pieces kind of get caught in the gel and they stay up at the top. So what you are going to do here, just for an example, we are going to look at this and we see our first one is 13, 10, and 17. So let's do a segment that's 13, 10, and 17. So you can do anything you want. You could just put like a word in the box or something like that. But what I suggest that you do is click on the box that you want to fill. So our first three are going to be 13, 10, and 17. And then up in the corner here where it says background color, just pick a color and fill in the box. So there is our 17. Let's fill in our 13 and then fill in our 10. And then I'm going to scroll up and look at all of the other ones and fill those all in. And remember, if we have two that belong in the same one, typically that would get us a thicker band. But for this, we're just going to fill in the box or not fill in the box. So I went through and I filled in. So we have a band at 17, 14, 13, 10, 8, 6, and 7. So that is going to be our banding for our chick. And then what we are going to do is do the bandings for all of those males. And then you guys are going to try to figure out which one is actually the dad of the chick. Okay, so you're going to try to do that from the gel electrophoresis. And then down below, answer the conclusion questions. So next week on Monday or Tuesday, whatever day you have this class, we are going to have an assessment on this. So it will be a summative assessment. It will be open notes because I can't force you to not do that, but it will be timed. So make sure you have all your stuff in front of you. You know what everything is because it will be timed. If you get kicked out, just let me know. I'd be happy to look at it and reset it or anything like that. But I hope you guys have a great day. Miss you guys.